Okay, I want to do one more area problem for you guys. Um, it's very similar but slightly different to the one that we just did. I'm going to use the same cardioid, the 1 plus cosine theta. So if I draw that, I'm starting here, theta equals 0, gives me r equals 2. And I go like here, I got this one, and then that one, and there's my cardioid. And then I want all the circle r equals 3 cosine theta. So remember what we did with these circles, actually, that's not a circle that is centered at the origin, right? That would be like r equals 3. This is a circle that's centered over. If I put theta equals 0 here, right, I'm going to get r equals 3, that's here. And what I'm going to do is as theta goes from 0 to pi, I'm going to trace out this thing which is supposed to look like a circle. Whatever. Pretend it looks like a circle. Somewhat circular in its nature. So we want this area out here. Okay? Eventually we want the whole area, but again, because of this kind of mess with the with these points, I'm actually just going to do 2 times the area up here. Now, what do I mean by say these mess with these points? Okay, this example in particular is kind of interesting if you see how it gets drawn out. If I start from theta equals 0, we're fine, right? We started here, and as theta goes from 0 to pi over 2, we do this, right? And so that point's fine. Going to be fine. But then what happens is I continue on. I go through this. And then if I was going to look for that other point, I'd have to continue going around the circle again. Once to here, and then finally to here. Okay, so, and then you can do that. It's not that you can't, it's just a little bit weird. Okay, so you would have to do it from the negative to the positive to get that. Another thing that I wanted to point out about that is if you saw the way I did that, we can see for these curves, it looks like there's 3 points of intersection, right? Because they clearly both go through the origin. But the way I drew it, my finger wasn't at the origin at the same time for both curves. So when we solve for it, those points of intersection, we won't actually get the origin. It doesn't matter for us for this problem, but it's just something I wanted to point out because in case you did need to solve for something and it wasn't coming up, it might be something weird like that. Just so that you're aware of it. So what I'm going to do, I'm going to do area being twice this shaded region, which I still have to figure out what those are, right? But my outer curve is going to be that circle. So that's going to be 1/2 of 3 cosine theta squared. And I'm going to subtract the inner curve. So the inner curve along my R is going to be the cardioid. So that's going to be 1 plus cosine theta quantity squared. Okay, so all this. Okay, but now I have to figure out, and I do know what the bottom is 0, right? Because we can't draw 0 today. Okay, we found out that at theta equals 0, we're here, and that's where we want to be. But we want to find out, we need to find out what theta corresponds to that point of intersection. So we're just going to set these 2 equations equal and solve for it. So what I get, okay, solve for the limits. I'm going to do 3 cosine theta equals 1 plus cosine theta. That's going to give me 2 cosine theta equals 1, or cosine theta equals 1/2. Okay, so what does that give you? It's going to give you pi over 3. And so I can think about theta equals pi over 3 And then the other one is going to be down here, minus pi over 3. So if I wanted, I could do minus pi over 3 to pi over 3. Or I can also think about this as being 5 pi over 3. Okay? But I don't want to take the integral from pi over 3 all the way to 5 pi over 3 because that would give me this portion. So it just depends on how you want to do it. That's really why I like to break it in half. Okay, so this is the integral that I'm going to do. And as you see, I've got a bunch of cosine squared crap. So let's work this out. Got 9 cosine squared minus 1 minus 2 cosine theta minus cosine squared. Okay, see, because this minus goes in there. Okay. So basically I write 8 cosine squared theta, but I know I have to use my half angle formula. So I'm going to do 8 times that half angle formula. It's going to be 1/2 1 plus cosine 2 theta. Yeah, all right. All right. So I'm going to integrate this. This is going to be 4 theta plus 2 sine 2 theta minus theta minus 2 sine theta from 0 to pi over 3 and out of space. Okay. I'm going to bump over here, I guess. Evaluate that. I actually have 3 theta, right? 4 theta minus theta, because I should have put them up there, but I didn't. Okay, so I've got 3 times pi over 3 plus 2 sine of 2 pi over 3 minus 2 sine of pi over 3 minus 0, 0, and 0. Okay? So, but sine of 2 pi over 3 is root 3 over 2, and sine of pi over 3 is also root 3 over 2. So these two cancel out. And my answer is pi, which is in fact the right answer. Right? Since sine of pi over 3 and sine of 2 pi over 3 are both the same. Okay? So that's another example of this kind of thing. We do need to know how to do these. Some of them can be very painful. I hope I didn't give you any that are particularly painful. It should be something that maybe you do need to solve for an intersection, but it shouldn't be something completely awful. As I did try to pick them to be somewhat reasonable. Because it's important to be able to work with the polar coordinates and the polar curves, especially the circles that are off kilter and circles that are in the center and stuff like that, that you'll definitely need to know. Like the weirder ones are not going to be something that shows up very often in Calc 3 or the rest of your life, to be honest. But just understand, like, circles all the time, of course. So it's a good thing to know how to do that.